if you are having trouble with the faucet, don't worry too much about it. It will inhibit a little bit of running our application, but you'll at least be able to like run through the whole setup process and everything. Now that you have a node, even though your node has nothing on it, network does not acknowledge its existence. Alternatively, what you could do.
Do you have any other faucet?
Yeah.
Sources?
So one thing that might work better. So I just threw up another URL down here. Testnet faucet.mempool.co. So what we're doing with that first faucet is we're asking someone to open a Lightning channel to us, which means they need to find us on the network. Like they need to find our node on the network. And sometimes that is a problem when you're on like shared Wi-Fi or like you're not on a home setup where you can forward ports and all that stuff. So what this faucet does is it's not for opening channels, it's just for sending you Bitcoin. So what you'll want to do is hit that receive button in Zap and start getting some Bitcoin into your node. And then you will open a channel to someone else. It's a lot easier to open channels than to get channels open to you. That's just kind of a quirk of the Lightning Network. So feel free to try out that second faucet and give it a Bitcoin address from Zap, not the pub key.
The TBTC.
Yep. Yeah.
That works. But that means you only have liquidity on one side, or is it the same thing?
It is only liquidity on one side. Using your neighbors around you here, we might be able to.
Be a fun exercise.
Yeah. Might be able to push some Satoshis around that way.
We're going to need to test that block you go through, right?
Yeah. So all of this, unfortunately, is inhibited by that lovely 10-minute block time. That's why we're getting on the Lightning Network to get around that. So Hannah, whenever.
Okay. Yep. I'm just gonna do all the announcements and stuff.
Yes.
For the benefit of YouTube. So hi, I'm Hannah. I think actually there's a few people I don't know. Hello. So I'm one of the organizers. We have two other organizers, Ian and Chris, who are not here at the moment. Chris is actually upstairs in another meetup. But it's my fault. I scheduled it the same day. So we are streaming on YouTube. Hi, YouTube. If you don't want to be on YouTube, stay back that way. We do work off donations, but I've been informed that we cannot do any kind of like actual transaction in the building. So we can't accept any donations during this event, but we will be headed to the bar afterwards, and we'll have our lovely donation jar with us and our tablet where we can accept credit cards. And of course, you can go to bob-shy.org/reckless and donate via the Lightning Network there. Bathrooms are over there. I need to thank Metis, who is letting us use their very nice space this afternoon. Metis is a data science educator. They do on-site boot camps, corporate training, and online training as well. If you have any questions, Nathan back there is your guy to answer questions about that. All right, we also have some snacks in the corner. Help yourself. Today, Will O'Byrne is going to tell us all about Lightning apps. He is working on Joule, which is a browser extension, which is very cool. He told us all about it at Magical Crypto, and that was a very cool presentation. And he is going to walk us through the process of setting up a Lightning app. So, thank you, Will.
Yay! Thank you. Thanks, everybody. So I had some instructions up here for before this whole thing kicked off. Unfortunately, I didn't really thoroughly plan on the setup aspect of it, as you never do. So I'm going to be popping away from this slide. If you have any questions, though, about node setup and stuff, we'll do a little workshopping portion where we'll actually kind of set up the code to run, and I can help you out then. But otherwise, let's get started. So I've got slides. If you would like to follow the slides on your own machine, maybe you are myopic or the other one, or there are a couple of links in here where you want to study these later on your own time, you can go to tiny.cc/Chicago lap slides, Chicago-lap-slides. Follow along at your own pace. So as Hannah introduced me, I'm Willow Byrne. I work on Lightning stuff. Lightning is really cool because it's kind of made Bitcoin payments on the web very feasible, and even more fun if you are a developer. It has made earning Bitcoin a lot more fun than going to an exchange or something like that. So I'm going to pop away from this slide. If you need that link again, let me know. Should mention what I work on. I work on this browser extension called Joule, which you will see later. Basically, it makes interacting with the web a lot nicer than using a command line. It hooks your node directly into your browser, and you can make payments and all sorts of other cool stuff without ever leaving the browser. I've also worked on some Lightning apps to kind of test out how the network works. Most recently, I worked on something called TipHub, which if you followed like a lot of Twitter craze, you might have been familiar with Tip&Me, which was a custodial tipping app. Well, I wanted to put power back into users' hands, and so I made a non-custodial tipping app. So this thing actually directly facilitates user transactions to each other. There is no node running on this website. It just hooks other people up. So what we're going to be talking today is about techniques that you use when creating a Lightning app to actually facilitate that communication directly to a node instead of just updating balances in a database and keeping track of users' money. We're actually going to be sending and receiving payments here, which is pretty cool. So before we get started about building Lightning apps, let's just do a brief refresher on what exactly Lightning nodes are and what we can do with them. So nodes are, first and foremost, they're just a regular wallet. If you've ever set up a Lightning node, you've probably had to go through the 12 or 24 word seed phrase thing. You can send on-chain transactions. They're just another wallet at the basis level. But then on top of that wallet, you've also got this database backing it. And that database keeps track of other nodes on the network and their current state so that you can do things like know who's online, know where to route payments, be able to identify people who are also on the network. That's all stored locally on your machine in your own database that the node runs. Nodes are also an RPC service that communicates with other nodes on the network. So nodes will both broadcast information about themselves as they have things to update, but other nodes can also talk directly to each other and say, okay, like, what's your current balance? Or what nodes are you connected to? All that good stuff. And kind of the coolest thing about nodes is that nodes are effectively just API web servers that we can build apps that talk to nodes. So if you're familiar with like other payment APIs like Stripe or Google Pay, PayPal, whatever it is, you can kind of think of a Lightning node as a host your own version of these services. They're a way to replace those kinds of payments where you can be censored or you have to pay like hefty fees to the service provider, or you have to deal with getting your account locked, stuff like that. You can host your own payment infrastructure with a Lightning node. So as you saw before, there are 3 main implementations right now. There are a couple of others in development, but these are the 3 node implementations you'll most commonly see. On the left, we have C Lightning, which, as the name implies, is written in C. That's kind of sponsored by Blockstream. They're putting a lot of development effort into it. In the middle here, we have LND by Lightning Labs. This probably is the one you're most familiar with. I believe it is the oldest implementation, but it certainly has the most development effort on it right now. And then on the right is that is the logo for Eclair, which is kind of a mobile-focused Lightning node. So they also have a mobile application. They're working on trying to optimize it for mobile data and mobile devices primarily. And you mostly see it kind of in that space. You don't really see it used too much on desktop computers or backing applications. So we're going to throw those other 2 aside for today. Even though all Lightning nodes conform to the same spec, at the network level, each node behaves very differently, kind of as differently as those other APIs I showed you, the traditional APIs. So we're going to focus on LND today, just so that we're all on the same page. So LND is the most actively developed node implementation so far, and typically the first to implement new features. So while it is good to kind of hedge our bets and have multiple implementations that will overall increase the robustness of the network and make it so that no single point of failure in the node implementation will totally take down the network. If you want to keep up with the latest stuff in Lightning, LND is usually a good place to be working with, or a good node to be working with, because it often has those edge case features that are coming out. It has really great REST and gRPC APIs that are well documented and tested. If you're not familiar with gRPC, it's kind of a lower level communication protocol than REST. It tends to be a little bit more optimized. So we're actually going to be using gRPC today, but don't worry, you don't even have to learn it to use it. It's basically like any other RPC call. You make a request, you get data back. It's all good. It has this really cool, unique feature that most node software I have not seen have, which is permissioned authentication. Using these files called macaroons. You can think of a macaroon like a fancy cookie, like a browser cookie. It's just a little piece of data that you present whenever you want to do something, and it determines whether or not you can do it. But in this case, they're permissioned. So in LND, you have these various macaroons that give you levels of permission so that you can run your node and have people talk to it online, but they don't have the ability to spend your money. Maybe they only have the ability to get information about your node, or they have the ability to generate invoices so that other people can spend money to it. So this is a unique feature of LND that I really think makes it really great to work with. There are tons of useful libraries for developing with LND. We'll be using some of those today and looking at them. But in general, most developers working on like web server software, so if you're writing in Python or JavaScript, you're going to see a lot of libraries that interact with LND and not quite as many that interact with the other ones. So it kind of makes it a good thing to work on for web developers. So I'm just going to quickly throw up some LND development resources. This is mostly for you to look at on your own time. We're not really going to dive too much into these, but if you want to start building stuff on Lightning using LND, these are the places you're going to go. There's a developer site that has, it's just got a bunch of friendly links. The most important one is the API links, which just outline all of the RPC endpoints, what they do, what they take in, what they return. And the last one is an initiative taken on by the Radar Relay team. If you're familiar with them from the Ethereum world, they're also really focusing on Lightning right now. So they put together this team called ION, and they're making it.
Can you read out those links real quick for the people that might be watching and can't quite read that?
Oh, yeah, absolutely. So the first one is dev.lightning.community. The second one is api.lightning.community. And the third one, the Radar ION guide, is ion.radar.tech. So yeah, just check these out on your own time. So let's get started with building our own app. What we're going to do is we're going to clone an existing project, do a little bit of environment setup, because everyone's got their own nodes, so you're going to have to set it up specifically with that. And we're just gonna run the app, and then we'll talk about the code after we've got the setup going. So I'll just throw these instructions up. So I've made a little GitHub repository here at github.com/wboburn. Sorry for people who can't read. There's no way you're going to spell it. Chicago-Bob-Lab. If you pulled up the slides from earlier, you can just click on the link in here. And you're going to want to clone that repository somewhere on your local machine. And you can go through the README in there to set up your application. I'll be doing it here live, so don't worry if you don't want to dive in on your own. We can do it together. And then once that setup is done, we'll actually be able to run this thing. So I'm going to leave this up for just a little bit so that people can pull up the link and clone the repository. As I noted at the very beginning, you're going to want Node.js to be able to run this, and you're going to need a Lightning application to run through, or a Lightning node to run through the app setup. All right, so I'm going to start to do this here live as well. If you feel confident in what you're doing, feel free to go about it yourself. But if you just want to watch me do it, that's cool. And if any of y'all have any questions, please feel free to interrupt while I'm going through it. I don't want to just do all this stuff and have people wondering what's going on. Okay, so yeah, popping over to the repo. So here we have it. You can grab that URL for cloning if you click the clone or download button. Makes it easier. And I'm going to go into my documents folder and I'm going to clone it. This is going to put it into a directory of the same name. We'll go ahead and CD in there, Chicago Bob Lab. Now let's take a look at what we have here. It's not too many files, and I'm going to skip over the basic like project ones. So we've got a .env.example. This is a pretty common practice in projects where you have these environment variables and they sit in a file, but those never go into source control because they contain secret information or they contain information that's specific to the machine. So this is an example of what that will look like. We've got a README that's pretty handy. We've got a nodemon file, which you can mostly ignore. It just tells Node what processes to run and what files to watch. We've got a package.json, which is in every Node file, Node project. And then we've got the server folder, and that's really where our code lives. Like I said, we're going to come back to the code a little later, but that's just what we've got here. So as I said, we're going to go through the README and do our setup. So this is just some basic description. Here are the requirements. I've got that set up. Hopefully you do too. And then we're actually going to go through project setup. So the first thing that we're going to do is we're going to copy that .env.example file, and we're going to make one of our own because we're going to override some of those variables defined in here. Let's see what the README says about what we're supposed to do with them. LND gRPC URL. Like I said, we're going to be using the gRPC API. If you set this up on your local machine, I think all of y'all used Zap before. You're probably all going to enter the same thing. To get all this information, you're probably going to want to follow this link in here that I built. It'll help you find where this stuff exists on your computer because, like I said, every node setup is different. There's a bunch of different node types and a bunch of different operating systems, and they all are a little different. So we're using Zap Desktop, and I'm on Mac OS. So it's going to tell me where to look for some of these things. So this tells me that my gRPC port is 11009. So I'm going to copy that. So this says it should be 127.0.0.1. That's the IP address of your local machine. And then even though this suggested 10009, that's the default for LND. We're using Zap though, so we're not going to be following the defaults. So I'll go ahead and punch that in here and fix it. Oh, cool, that works. Is that easier for you all to read?
Yeah.
Right on. So this is probably what you're gonna want to have set up in here. The next two things get a little trickier. So we're going to need our macaroon, that's that authorization file that I mentioned, and we're going to need a TLS cert. If you're familiar with like HTTPS, that is what it uses to encrypt and decrypt data. It's using TLS certificates. So we're going to need both of those to make sure that we're authorized to make requests to our node and that those requests are done in an encrypted way so that people watching on the network can't steal our data. The way we do this is because these are files and not strings, is we base64 encode them. That's just a way of taking arbitrary data and smashing it into all the letters in the alphabet. And you can do that on your command line by running the base64 command, probably. If you're on Windows, you might not have base64, but I believe that Mac OS and Linux should come with it. And so where you're going to find these two files, these LND macaroon and LND TLS cert files, is again going back to that helpful tool to tell you where to go. It'll possibly be different for you depending on what your operating system is. But for me, it'll be here. So I'm going to go ahead and open up just a little new tab in my my terminal, and I'm going to go to where it said I should. And it says it's not. Oh, that's because it's got a space in it. So, gotta,
Slash.
oh yeah, there we go. Okay, so yeah, unfortunately, for some reason they decided to put spaces in folder names. It's a really bad idea for terminal usage. And if we check in here, we'll actually see that I don't have them, and that's because I forgot that I was going to walk through creating a wallet with you guys, but I did it with you all beforehand. But let's just go ahead and do that really quick for the folks on the stream. So this is what running through the Zap setup looks like. It's going to generate a 24-word phrase, which you should never stream to the entire internet. But we're going to go ahead and do that now, really being reckless. It'll ask you to punch some of those words back in to make sure you copy them down right. You really should be writing these down. I'm not going to do that live because that does not make for good TV. And then a password. I'm not going to tell you what that one is. And this will be my Chicago wallet. And we're going to be using the testnet today. And we're going to disable autopilot. That would just automatically open effective channels for you, but we're going to go manual today. Don't worry if you did this yourself. So it's going to start up. And now actually, I should start to see those files come in pretty soon here. Okay, so you have to work your way down into the Zap folder structure to find it. So I'm going to go to Bitcoin and testnet because Zap actually lets you have multiple wallets, which is kind of a feature most wallets don't have. They just generate one wallet for you. So you're going to want to CD into the Bitcoin testnet folder because we're doing Bitcoin and we're doing testnet. You could conceivably have other currencies and be on mainnet. And you're going to want to find which wallet yours is. I think mine is wallet 2. And here my files have now been populated. So it's in the Bitcoin testnet and then wallet dash. Yours might be wallet 0 or wallet 1 if this is your first time setting it up. So now I found my TLS file, and that's good. We're going to need that. So I'm going to grab it with base64. And I'm looking for the tls.cert file. And so it just spits out a bunch of characters. And we're just going to grab the whole thing. Make sure you grab every character in it. And once you've got that, we'll go back to our code and put it in the env file. So now our application, our node application, will be able to read this file and grab that data. And we're going to go ahead and do the same thing for the macaroons. Those are unfortunately even deeper in. So we're going to go into data and then chain and then Bitcoin testnet. Zap really nests this stuff very deep, which is a little annoying. I'm flying off the screen here. And so deep down in that folder, you'll see a bunch of files, most of which we can ignore. But you'll see a few that end in macaroon. So you've got an admin macaroon. This lets any application do whatever they want with your node. They can destroy the whole thing. You know, they could open new channels. They can spend your money. We would only want to use that if our application required the need to do all of this. We've got an invoice macaroon, which lets applications generate new invoices for us. So they can't spend money, but they can identify our node on the network. So you might leave a little privacy there. And they can request new funds. So this is really great if you're building an application that only needs to receive money, but doesn't need to send money back out. So for instance, that TipHub site that I showed you earlier, it only requires invoice generation. It doesn't actually send money to anybody. It just allows them to receive money. So that's what that one does. And the one that we're going to be using right now is read-only. And this one doesn't let you spend money, doesn't let you receive money. Just lets you run some basic calls on the node to check information about it. So we're going to do that base64 thing again on the read-only macaroon, and this time we get a slightly shorter blob of data. I'm going to go ahead and copy all of that and paste that in here. Cool. Port, we're not going to change. We're happy with the default there. You can leave that one the same. So I am happy to help folks figure out how to get these three in just a little bit if you ran into issues. But let's just carry on for now, and we can take a little break and run through that together shortly. So that was it for setup. We just needed to grab those three pieces of information, the gRPC URL, the macaroon, and the cert. And now we can install our node dependencies and run the site. So I'll close out this tab and go back to the one that's in my folder. And I'll run an npm install, or if you have yarn, you can run yarn. Don't worry if you don't. This will take a little while, especially if we all run it all at the same time while streaming video. So take a break here. Worked hard.
Slowest thing I've ever did using JavaScript.
Yeah. If you haven't checked out Yarn as a package manager, I suggest doing that. I was just going to use npm to make it easy on everybody, but Yarn does a lot of cool caching and optimizing that makes package downloads faster. Just so I get a feel for the room, how many people were able to find their cert and their macaroons? All right, a couple of folks, right on, cool.
I'm typing base 64 TLS and cert.
You're getting base 64 is not a command?
Yeah.
Okay, cool. Let me just take a quick detour because I'm sure a lot of other folks have run into that. If you just search like base 64 file online, don't worry, this is all testnet money, so you don't have to worry. You can just find a website where you can drag the files in and it'll run it for you. Unfortunately, not all operating systems, not all distros come with it. I don't know why it seems.
recommend a node version or just the recommended one?
I would take the latest LTS, they call it, long-term support. I would just grab whatever the latest one is. We're not going to be doing anything too fancy. Cool, that sounds good. All right, so we installed our packages and now we can run it. And so if all went well, you should get to this server started line. And then even then, we'll want to load it and make sure it works. So I'm going to go here and voila, some info about my node. The web server and the node are talking. It's beautiful. It's amazing. You've never seen anything like it before. If you didn't get that, that's okay. We'll do some debugging shortly. But the best way I find to debug code is to first understand what it does so that we can find where the problems are. So I'm going to do a quick walkthrough of the code here. It's pretty simple, but I'll do that and then we'll take a little break just for everyone to try to work this out. And I'll come around to folks who might be having trouble. So as I said, all of our code is hanging out in this server directory. You got a few files in here. I'll start from the top. So env.ts, just as a heads up to people, this is using TypeScript, not JavaScript. It's almost exactly the same. In fact, you could write plain old regular JavaScript and it won't give you a hard time. It'll run just fine. So don't worry about that. If you don't understand some of the keywords here, it's basically just JavaScript. All this does is load our .env file and put it in a nice object. So it's just taking those variables from that file and putting them into JavaScript. And if you're missing any of them, it'll barf at you. So it's handy, but it's just a helper file. Don't have to worry about it too much. Let's jump over index and go into node.ts for a moment. This is also a really simple file. We're creating an RPC interface between our node and our JavaScript application. This is using a really handy library called LNRPC. It makes it so that we don't have to handwrite requests for everything. This actually creates a nice RPC object that we can just call methods on. So we hand it the URL, the cert, and the macaroon that we added to .env. We'll initialize this thing. This will just save us from writing a bunch of code of having to deal with gRPC buffers and a bunch of stuff we don't want to be doing. We want to be building an application. So that's all this one does. You call this init node function, and you get this node variable all set up for using. And then the big file that we'll be using, how many of y'all have written an Express application using JavaScript before? Okay, a couple of hands in there. Express is a very simple web server, which is what we'll be using today. All it does is sets up routes so that when you make HTTP requests to the routes, it responds with whatever you wrote for it to respond in code. So the very first line, we create our Express server. That's it, nothing too special. The next set of lines here is we're calling the get method on the Express server. A get request is the request you most commonly make in a browser. So you hit a web page. If you go to your browser, type in a web page, and hit enter, you're firing a get request. What you're doing is you're getting data at that resource and you're bringing it back into your browser. So whenever someone tries to get / which is the home page of any site, you might notice most websites have a trailing / at the end. What we're going to do is we're going to talk to that node object we created, and we're going to ask it to get some info about the node. And then we're gonna send that info back as HTML to the browser. And if anything goes wrong, we're gonna pass that error back off to Express and let it render an error for us. So that's the one and only route that our not so complicated web server has. And then if we go down to the very bottom, we're just initializing everything. So we're running that init node function I showed you before that initializes our RPC interface with the node. And if that all goes well, then we start our server. And this might yell at you if something was wrong about your setup. And so that's all this is doing. This is only really 40 lines of code to kind of set the baseline for a Lightning application. So, all right, quick show of hands. How many people were able to get this screen? You got it? You got it? Cool. Don't worry. I totally expected that this would be a sticking point for folks. So what I'll say is let's try to time box this a little bit. And I'm going to give folks 10 minutes to try to catch up and get this screen. And I'm going to come around and try to help anybody who might be running into some issues. If you have an explicit error, that's a great starting point because that means you actually got it to run and something threw up at you. If you're just not really sure what to do, don't worry, we'll keep trucking through this and you don't necessarily need to be writing the code or setting it up yourself to follow along. But let's take 10 minutes, come back at 7:56 or I think 6:56, I'm sorry, I'm on East Coast time. And we'll keep going and try to keep everybody with us. Is that cool? All right. Does anybody have like an error message that they just like want to throw in front of me and have me decipher? Anybody?
No, but can you remind me where to find the TLS cert macaroon?
Yes. Okay. So did you run Zap?
I'm on BTCD.
Okay. So having a Bitcoin node isn't enough. We also need a Lightning node. Do you have like LND?
I do have LND.
Okay. You have LND? Cool. So if in the README, there's this link here to a little Lightning Joule tool that I wrote.
Okay.
Right on. Okay, so you have that open. So you want to choose LND command line as your node type, and then it looks like Linux as your operating system. Cool. So it should just be in your home directory in .lnd.
I found the read-only. What is the name of the TLS?
Oh, it's just tls.cert. And it should be at the top level, so you don't have to drill down into, yeah, that's the one, tls.cert.
Got it.
Cool. Yeah, unfortunately, they're not all in the same directory because you can have one Lightning node or you can have one Lightning instance that runs on multiple networks, multiple coins. Cool. Anybody else with like an error or something they?
I'm trying to B64 in code. So I'm able to drag and drop the TLS cert. Okay, this block, like that.
It looks like base64. It doesn't look like a TLS. Like that dude in the Matrix who. Well, so yeah. So which website are you using? Did you do the cert or the key?
Well, the cert.
Okay, cool. Yeah.
Try that. Drop that here.
You know what I think? Oh, so this is actually just a cert file. So what they're looking for, what that actually does is literally just opens this file. And you grab a cert. They don't have like tracking account built in. So let's see if we can find a website that specifically works with all the files. Yeah, so this one might work a little better. Yeah, give that one a shot. Thanks. You all good? Or sure.
So, this just.
Yeah. So this is doing like the neutrino thing. And yeah, unfortunately, I didn't really profile like how long this would take.
No, that's fine.
So we might get to the end of this and you might get like 50%.
Yeah, that's fine.
Cool. But you should be able to still, all these steps should be done. Yeah.
Yeah.
Okay, cool. Right on. Yeah, all this means is that you won't be able to open channels or receive Bitcoin until that's done. But you can still. Cool.
I'm getting this show,
Okay.
but also this one is not connected, so that's my new one.
No, unfortunately, I don't think that faucet's gonna come through, just because we're all on the same closed network right
Okay,
now.
well, I tried it with the big
Oh, interesting. Okay. That actually, yeah. I'm not 100% certain. I've always done this at home when I like forward all the reports and all that. But the error you're experiencing, yeah, it's unrelated. So this probably means that it's not able to talk to your node. So can I see your .env file? Okay. Yeah, this all looks pretty good. Did you, are you using Zap or did you set up your own LND? Okay, cool. I think what you need to do is change the port.
It's gonna be different here, or?
Or can you go to your EMD file? So this 10009 is the default for like the command line utility.
Oh.
But I think you want, I can't remember, can you open that tool, the tool here? And select Zap. Scroll down to Zap.
Oh, okay.
So try that. Cool. And then you'll need to restart the node app. Alright, let's try it now. Okay. Well, it wasn't magical with that. I thought it would be. I feel like I've seen this before, and I'm trying to remember where. Let's see. Can you go to Zap? Let's see. Can you hit the QR code? Cross and check LND. Okay. Yeah, it's up now. 11:09. Yeah, they just have stuff. Yeah, they encode it slightly differently, unfortunately. So you can't just copy this, but let me circle back around that and just make sure. I would say try to make sure that the LND cert got encoded correctly. Can you show me they did that? Okay. Yeah. Oh, you know what? That looks different than what I saw in your file.
Oh, yeah?
Yeah. Can you copy that again?
what?
Yes. So. No, I'm good. Those look right. Try pasting that in. Yeah.
Make like a test wall
And
and
then
then
download
like networks. And then
Yeah.
have it install. So I guess let's try to restart it.
No, it's all good. Hey, all right, it was one of those. Cool.
That node, or that channel open, but have other ones.
Oh, dope. Yeah, that's awesome. That's perfect. All right, cool. Anybody else running into any problems before we move on? Okay, cool. Looks like we got a few folks off the ground running. If you're still caught up with some of this initial setup, don't worry. We'll cover the code, and you can always catch up on your own time. And of course, I'm available to answer any questions you might have, either after the session today or online later. Right on. Let me just real quick check out where we're at. Good. Okay, cool. So we got our app running, but it really isn't much of an app. It was basically just a plain text HTML page that printed some JSON data. It's not really fun. So to actually use Lightning not just as this info dump, but as a way to power our application, we're going to implement payments and WebSockets and hook those together to actually get payments to run through our app. So let me take a step back to just talk about how Lightning payments work and how we'll be using them. So Lightning payments all happen through these things called invoices. Typically, a server provides you an invoice, and then the user will pay to that invoice. So here on the right, you see this website, BitRefill. They sell like gift cards and stuff, and they let you pay with Lightning, and this is generally what that payment process looks like. These invoice things are this long encoded string. You can see it here where it starts with LNBC, that stands for Lightning Network, and then identifies it as on the Bitcoin Lightning Network, and then a bunch of other garbage. That is an encoded string that includes some very specific stuff, such as the amount that you have to send, how long that send will be available for and when it expires, a description of what you're buying maybe, where it's going, potentially some hints about how to route it. It includes a bunch of stuff. This is actually really cool because in Bitcoin, if you've ever sent money with Bitcoin, you get an address and that's it. So you kind of have to make sure that you send the right amount. You have to set your own transaction fee. You have to, there's a lot that you have to do right. You might wait too long and then the website cancels your order, but then your send goes through. You might get stuck in the mempool, all that bad stuff. This is all condensed into one single string that we can just present users with and they can make a payment to it. And it's all done. Those payments, once they're made, settle nearly instantly. So unlike a Bitcoin purchase, where you have to wait for a few blocks to get mined for them to really be confident in your transaction, these happen immediately and you can move on. And so when we're making our applications, these invoices can either come from a server Lightning node, which is what we'll be doing today, where you as the app developer run this one node that the server kind of talks to, or it could come from other users. So you could think of a way of having users communicate invoices to each other and have them pay each other. It doesn't have to be this centralized way that we're going to build it today. You could make it very decentralized and let people provide their own invoices. WebSockets work really, really, really well with Lightning. So if you've worked with a web server before, most of the time they do HTTP requests. These are a one-off request response to a server. So I send the server some data about what I want, and the server comes back and gives me a response to that request. Once you do that, you have to do that whole handshake thing, and then once the request is done, there's no more persistence there. WebSockets are cool because they're nearly instant for starters. So HTTP request, there's a little bit of time in that handshake process where the server has to make sure your request is all good and establish the connection. WebSockets, you establish the connection up front and then you have really quick responses back and forth. They're bidirectional, so a request response, you can only send data once and they can only send you data back once. Here we can send data back and forth all the time. And so by using WebSockets with our Lightning apps, the user can see updates on the page as quickly as the Lightning payments go through instead of having this kind of asynchronous process where they like refresh the page or come back later. So I have a real app, not just one that displays information, and it's in the same repository that you just downloaded, but it's on a different branch. So in that repository that you just downloaded, you're going to check out a new branch called LAPP, L-A-P-P. And you're going to want to follow the README to do a little bit of adjustment to set up our application to actually be able to take payments. So what we're going to do is we're going to change that port value and change the macaroon. If you were using the read-only macaroon before, we're going to need a more powerful macaroon. There's more information in the README, and I'll go through it in front of you. And then we're going to add this new variable called API path, because now we're going to be using our server like an API instead of just plainly serving up stuff. And then you can run it just as you did before. So let me jump back to the repository. So on GitHub, you can browse these branches, and you'll see that I have a few here. We'll jump over to the LAPP branch. And here let me make this bigger. Here we have a new folder called client. So before we only had server, now we actually have a client. That's going to be our front-end application. There's a lot of stuff going on in here, and I'll explore some of it with you, but I'll also let you guys do some of that on your own time. Think of this as a jumping off point for learning. But we'll go through the README now. So we're at the second part of the workshop. So you should have already done most of that initial setup. Here we're going to make some changes. So as I said, we're going to adjust the port value. We're going to add an API path, and we're going to adjust the macaroon. So let me do that with y'all. Here, so I'm going to close out of my server. I just had it open. I'm going to check out the LAPP branch and make sure that I have the same stuff I saw on GitHub. So yeah, now we have this client directory. That's new. And I'm going to go back to my code editor and open up my env file. So you could just do it directly here, or you could use the env example as a point of reference, and you'll see it's slightly changed. So we've added this API path thing. So I'm going to go ahead and copy that in and get that updated. But this suggested that I move the port up to 3001. The reason this is now we have two servers actually running. We're going to have a server that serves up our client code and a server that serves up our Lightning API. So I'm going to adjust both of these to 3001. That will make it so that the server, the thing that runs in the background, that's on a different port, and our front end is still going to run on 3000. We're going to keep that the same. So we have port, we have API path, and then the last thing is we're going to need to upgrade our macaroon. So before, you could have just used the read-only macaroon, but now our new application is actually going to need to generate invoices. We're going to get paid here, so we're going to grab that invoice macaroon this time. So I closed it out because I'm an idiot, but I'm going to go back to where the Zap macaroons live, which I believe was in library application supports, Zap, LND, Bitcoin, testnet, wallet 2, data. Keep going, and great, I'm back. So hopefully you saved that up from before. If you didn't, you can use that tool linked to in the README to find it again. Yours will be slightly different. But we're going to do the same thing we did before with Base64, except this time we're going to do it on Invoice Macaroon. And this will get you a slightly different one. And you're going to go ahead and copy that and replace it in your .env file. So now we've got the port on 3001, the API path pointing at the port on 3001, and this new up-to-date macaroon. Everything else can stay totally the same. That's fine. That should be it for setup. So now we can just, one instruction I forgot to mention, we will need to run npm install again because we have some new stuff. for our front end server. So this is gonna take a little bit again. Everybody's favorite part, little breather. And I guess I can talk a little bit about that front end that we just added. So this is using React and Webpack and Bootstrap. You may be familiar. Has anyone here built a React app before? Okay, cool. We got some decent front end experience in there. React is just a framework for rendering HTML on the client. And the cool thing about rendering HTML on the client instead of on the server is that we can make changes. Oh no, Webpack, come on, man. Don't be desperate. You can make updates based on these requests to the server without refreshing the page. So that's how most modern websites work. React is a really popular one. You might have also heard of Angular or some others. And so I tried to run it, and we can see that I have an address in use. What that means is that something is already running on this port here, 3001. And given that I'm a software developer by trade, and for some reason people really like ports 3000 and 3001, I'm just going to go to all my other projects that I forgot to close out before I came here and close them out. And then we're going to run it again. And this time, it'll work great. So the first thing that you see is something started on 3000. We lost it. Something started on 3000 and something also started on 3001. So we've split. The thing that runs React will be on 3000, and that's what your users would see. The thing that runs on 3001 is your web server. That's something that users aren't going to see. That's going to all happen in the background. So we're still going to go to localhost 3000 like you did before. So if you run this and refresh the page, it should be fine. But it's actually going to talk to our Express server somewhere else. And now we have a cool looking website. It's not just text anymore. It's this like application. And so the application that I built for y'all that we're going to talk about today is I've dubbed it the King of Lightning. The way it works is that you make a post and you become the new king, and you're seen by all in the kingdom. But other people can take the throne from you. They can pay to replace your post. And that's basically it. It's really, really simple, basic application. So let's just see what that looks like. So there are no posts yet. So I'll make one. And I'll submit it. And so it presents me with that invoice that I had mentioned before. And I would need to pay that invoice. I'll admit there's a problem here. I just set up that channel, or I just set up that node, right? I just made it through setup. I don't have any money yet. You can see here that I just requested a payment. That was actually my website talking to my Zap node here. So this invoice, you'll see it starts with LNTB 10N. If I go in here, it's really hard to read for y'all, but I promise it starts with LNTB 10N. That's what happened, but I don't have any way to pay it right now because my node has no channels. There's no inbound capacity coming towards me. And so I'm guessing for those of you who just set up your node tonight, you're in the same spot. You probably don't have inbound capacity. Even if you did have inbound capacity, you can't send money to yourself. You have to have a different node send money to you. They don't let you do same node payments. So unfortunately, it might be a little hard for y'all to follow along for now to actually get this to work. But being the reckless person that I am, I have mainnet node set up. So I'm going to run on my mainnet node and run through this so that I can demonstrate it to y'all. But hopefully when you go home tonight, maybe you can get your testnet node funded and set up channels and all that good stuff so that you can try this out yourself. So I am going to jump over to one of my other projects. Yeah, this looks good. And I'm going to grab the .env file that I have over there. Actually, you know what? Yeah, I'm going to use this one. And I'm just going to replace this one. So the nice thing about this is like whenever you want to spin up a new project, you don't have to do the setup again. You just copy your old environment variables and they totally work. They drop in just fine. We'll need to restart our server. to have those take effect. So something went wrong because I killed the server, but if I tried to reconnect, it would come back up. It's pretty cool. I didn't even have to refresh the page. And now if I generate an invoice, I actually lied to you. This isn't mainnet. I realized it would be a lot easier to demo if I use this thing called SimNet. So one thing that's really nice that I wish I had time to run through tonight is most Bitcoin developers don't like spending their precious Bitcoin to work on applications. You don't want to run through all your money paying transaction fees just to try stuff out. So we run these things called either Regtest networks or SimNet networks, depends on your implementation. And what these do is let you be like the god of your own blockchain. So as someone who works on Lightning a lot, I need to test it out a lot, and I have a god complex, so I like to run my own SimNet. And I have a bunch of nodes on there, and I can just hop into any of them, make payments. The reason I didn't want to run through this tonight is it's really a pain in the butt to set up. But I'll totally send out a guide on how to run one of those yourself. If you want to try to work on this on your own, but don't want to deal with block times. So I've got this here, and actually if I pop over to my other profile, now I can actually pay it. So because these are happening all locally on your machine, it is a little faster than normal. But it's a great way to test things out. So that's how the application works. I paid that invoice, and I didn't have to confirm anything on the website. It was watching for that payment, and when that payment came through, it knew how to update the website. Was anyone able to get this website to show up for themselves? Okay, cool. Yeah, I wish I had planned that out a little better to get you all set up with SimNet. Unfortunately, no one has written a really good tool for that. To set up your own SimNet, it requires a little bit of development effort. You need to like write some code to get these things set up. Anyway, I won't dwell on that too much longer. What I will start to talk about is the code. And again, I'll break for a couple minutes and try to get everyone to render that other page and render an invoice. Oh, for those of you who got the page showing up, were you able to get an invoice to show up too?
Yeah.
Okay, sweet. Yeah, so I'll try to get everyone on that page before the night is over. So yeah, let's take a look at the code. So let's jump back to our old friend, the server. And server has gotten one new file called post. And index has changed a little bit. I'll come back to post later. But basically, you can think of post as this little black box class that lets us add new posts and mark posts as having been paid. So the main one is now we use a WebSocket for our communication. We're not using the REST API anymore, or at least we're not only using a REST API. We're using this WebSocket API. So you can make these. And what that does is it gives you, instead of a request and response object to deal with in Express, it gives you this WebSocket object. And WebSockets are really cool because you can just keep sending data down the line all you want. So what we do here is we grab the current post and we send that. We send that to them immediately. So when they first hit the page, they can see the post. But then we set up this little post listener. And the way this works is every time the post manager says there's been a new post, a new king has been made, we call post listener, and that also sends a post. And this will run forever. For as long as your web page is open, this post listener will keep listening, and every time a new post comes up, it'll push one to your client. This all happens really fast, which is nice. Then there's a little bit of boilerplate down here. This pings you every 10 seconds just to make sure you're alive, because otherwise some browsers will turn off the WebSocket. They'll assume you're not listening anymore. And then this little thing just handles, if I close the web page, if I close our WebSocket, I'm gonna stop watching altogether. So if you've worked with WebSockets before, a lot of this should look familiar. If you haven't, this is a really cool way to test out how WebSockets work. They're very interesting. We also have one other new endpoint here, which is a post request. So GET requests are usually when you type in a URL in your browser and you load it. post requests are usually when you submit data to a website. So you think of like posting it in the mail, or like sending this data off to them. What we do here, we pass to the server a name and some content. This maps to these fields, name here and content here. So we pass that. If they forgot to pass them, we're just going to throw an error, and we're going to say, hey, you need these. We make sure that the data isn't too long. So if it's way too long, we don't want them clogging up our server with all that data. And if it is too long, we just throw an error there. And then we're going to add a pending post here. This is just a little method that keeps track of our post, but it doesn't make it the king yet. Because in order to be the king, you have to pay for the post. But we want the server to keep track of pending posts because it has to watch them and watch for when they get paid for. So we add a pending post, and we also talk to our node to add an invoice. And the cool thing about invoices is they have this memo field. And the memo field is really cool because you can embed any data you want in it. And so what we're going to embed is a little message that says this is a King of Lightning post. Then we're going to add the post ID in there. And we can look that up later. So we're only going to charge them 1 Satoshi because we're nice and I'm not rich. And we're going to set the expiry in seconds to 2 minutes because we expect them to pay pretty immediately. We don't want that invoice sitting out there forever, and if they don't pay in 2 minutes, we can stop listening for it. If you set it really long, you can end up with a bunch of invoices that you're waiting on. Yep.
Is the reason why not leave that longer, just so you don't have to keep waiting for it? Or?
It's a few things. One is that let's say I generated this invoice for them, and then I decided that I didn't want to work on this project anymore, and I took the website down and went to go work on something else. Well, someone might have a payment in transition at that point, or they might have left the page open. And then if they pay to it, they're going to lose money, and I won't have given them the service they paid for. So it's kind of a cover your own butt maneuver, where it's like beyond a certain point, if someone paid you, you're not listening anymore. It's also a little bit of an optimization if you're a really high traffic node. LND is pretty fast, pretty strong. And presumably if you're a server, you have a pretty beefy computer. But anything you can do to just get rid of stuff that you're not watching anymore is usually good. It's just kind of a convenience thing.
So is there a way to check what your open invoices from LND?
Yes, there is. So what I could demonstrate, no, I can't demonstrate it. Maybe Zap can demonstrate. Oh, yeah, so Zap got rid of that invoice I had before because it's no longer open. There is an RPC endpoint for checking which ones are open. I believe I pop over to Joule here. Might take a little while. This is going all the way back to New York to talk to this thing. You can see this one's expired. This one's open. These are. I don't have any pending ones, but basically, you can check the current status of them. Cool. So back to this. So we've got this invoice. We've got this post. Once the invoice expires, we can get rid of the pending post if we want. I don't think I added the cleanup code here. But then we return to this to the user. So we're telling them, okay, here's the post as you gave it to us. And also here's a payment request back. And that is what what the client renders is that payment request in here for you to pay. But this is the end of the endpoint. It doesn't keep watching for that payment. What is watching is our WebSocket. So our WebSocket is going to check for when a new post gets made. Then it will tell the user. And that happens after we've started our server. There's a little extra code down here for subscribing to invoice changes. So one of the methods given to us by that RPC interface is subscribe invoices. And what that's going to return to you is this thing called a readable, which you can think of as it's very similar to a WebSocket, but it's on your own machine instead of between two machines. And so this readable, every time it gets data, we're going to process it. And so the subscribe invoice is readable. Will come back with invoices when they're created and when they're settled or paid for. So we're going to make sure that if it isn't settled and if it hasn't been paid for or it doesn't have a memo, we're just going to ignore it. So those are unpaid invoices or they're irrelevant to us. Like if they don't have a memo, they didn't come from King of Lightning. Then what we're going to do is we're going to extract the post ID from that memo string. So I'm going to go ahead and chop off the front part of it, King of Lightning post number X. I'm just going to chop all that off. And I'm going to turn that into a number. And if that didn't work, then this probably wasn't the right invoice. But if all that happened, if we got a paid invoice and we were able to extract an ID from it, we're going to mark that post paid. And the post manager will update the newest paid post. That will trigger the WebSocket post listener here and send that new data down. And that's the flow of data here as we keep that WebSocket open and listen on that stuff. So this is definitely like a pretty complex app. And the reason I didn't have us all write it together is there's a lot that it takes to get something like this working. But what I really wanted to give you all by the end of this was just something that you could play with on your own time and refer back to later and tinker with. So that's how this works. I kind of opened, I had some additional stuff that I thought I might run through, but I think it would be good for us to kind of just hunker down on what we have now and try to expand it. So what I would invite you all to do once you get this working is to try to make it your own, like try to customize the application. I find that I learn best when I'm messing around with stuff on my own. So you could just basically restyle it if you want, maybe rename it, change some colors, just to get a feel for how the front end works. A cool feature you could add is make it cost more every time you dethrone somebody, is make the price increase to make it harder and harder to replace the top post. You could change that instead of text posts that you let people post photos or you let people post links to tweets or links to other websites. You could change that from just basic text and you could render it for them nicely. Something that you could add is a persistence layer, and I have a tip of it, so that we don't lose posts, because as you might have noticed, if you were looking into the code, this is just stored in a JavaScript variable. So if I kill the site and start it again, we don't have a database backing this or anything. So come online, please. Yeah, there it is. There's no more post anymore. So you could try adding a database to it or a Redis instance or something stored in a file, even if you want to do that. There's a lot you could do to tinker with this and to kind of customize it for your own. So hopefully you can use this as a starting point to make a totally unique Lightning application of your own. Yeah, I was going to talk about hosting this online, and I have the slides here, and there's a guide there, but I think probably what would be a better use of our time is to try to get everyone like running this thing themselves. Does that sound good to everybody? Cool. Happy to talk about what hosting a Lightning app looks like one-on-one if anybody's at that point and they want to actually get this online, or you can go through the slides yourself and go through. There's a third branch on the project called Heroku, which will run you through hosting this online on Heroku. Except apparently, because I failed to push some code, but that's okay. I'll run through that one-on-one with anybody if they would like. Cool. And so I think with that, I'll probably just run around, help folks who want to. If that works. Great. Were there any just general questions about Lightning or Lightning apps before I kind of go one-on-one with people?
Any thoughts on like sort of scalability, like how many, when you have like a local sort of instance, like a small machine or whatever, how will that perform with how many people? Or
Yeah, it's a really good question. So for those of you who don't keep a close eye on Lightning, there's this nice website called 1ml.com, and they track the current, how the network's doing. So right now we have 8,500 nodes online. I'm hoping after tonight we have 85, so 85, 75. How many channels are open, how much Bitcoin is on the network, all that good stuff. So far, I would say that there haven't, in the small amount that we've grown over the last year, I haven't seen a lot of scaling issues. I definitely think long-term it's going to be a problem. Lightning has a few ways of coping with that. For one, all of our routing algorithms right now are really naive, or they're not that naive. I don't want to throw any shade on anyone who's working on that, but they are naive compared to where we're going to get. But even a basic like Dijkstra's graph traversal kind of algorithm is very efficient with a local database. So all this information is stored locally on your machine, so it runs through pretty quick. And I think it'll get us probably to 6 digits of nodes, no problem. Yeah, is it?
Yeah, in order to actually transact with like another node on the network, to connect and send money through like what's called
Channel?
channel.
Yeah.
Through channel. Don't you need to hold like 2/3 as much Bitcoin as they do?
No, it's channels are like, you can think of it as a string with beads on it, and you just push beads to either end. You need to hold a little bit extra to close it out on chain to pay transaction fees. Yeah, you can spend 99% of what you put into a channel. You can spend that. So yeah, just to get back to the scaling thing. So I think like we'll probably see it hold pretty steadily for at least the next year, I would say, unless there's some insane demand. But I think probably what you'll start to see is custodial nodes will probably be the most popular option for your average user. So for instance, sometimes when I'm testing mainnet stuff and I can't send to myself, I use this extension called Bitlum, and they just run a server for you. And all you do is feed it invoices and it pays, but they're holding on to all the Bitcoin for you and they're just maintaining their own database. So you're going to see those custodial nodes where one node might actually be servicing hundreds of users, thousands of users. That's one kind of place where scaling might go. There's also private nodes and private channels. So these are public nodes online. You could kind of think of them like public websites, whereas there are billions of online users. There are only millions of websites. Only so many people want to actually route transactions through them. Probably what you'll see is when you as a user come online, you'll open private channels and not announce them to the network and not be part of the routing graph, and instead just route through those people and they'll kind of route on your behalf. Some people are a little worried about the centralization implication there, but I think the hope is that like the market effect of cheaper routing and better uptime will try to keep people being honest to where they aren't charging crazy fees or they're not doing anything nefarious to the network because they want to maintain connectivity. So I'm very hopeful for Lightning scaling. I don't think we're like, nobody's boasting like Tron stats of like a gorillion transactions per second or whatever, but realistically, I think it goes pretty far. Any other just kind of general questions before? Yep.
What's the upgrade so you can receive a payment without an invoice? Send and receive?
Yeah, so that is called
What does
Sphinx.
that do?
Sphinx payments. I think they're renaming it because Sphinx is like a weird name. The way that one works, so all Lightning networks, Lightning nodes are talking to each other on the network all the time. And the concept of invoice generation and paying the invoices was to do a few things. It was to reduce overhead of the network so that they aren't all constantly like using the network to talk to each other to settle payments and negotiate routes and stuff like that. It's also like a convenience thing as a developer that you aren't having your channel liquidity like blasted. So if someone was kind of being nefarious, I guess they could push a lot of money at you, but it might disrupt your service. So it gives people a way to not have their channel balances messed up. The way Sphinx payments work are you basically just go to their node, knock on the door, and say, "Hey, I want to send you something." The innovation there was that it is privacy preserving, so you can do that without revealing who you are. You can just tell them, "Hey, I want to pay you," and they decide whether or not they want to accept the payment, rather than them deciding they want to receive money and telling you. So it could still, I believe, it could still reject a payment unless the whole route wanted to send the payment. But it was just a change in the initial design was just to do this invoice payment thing, and they figured out a way to do it without doing that. But it wasn't like there was no cryptography breakthrough there or anything like that. It's just a slight change to the network. I would not say that I'm like super well versed in the total underlying details, but I don't think it's anything too complicated really, other than just going to the node and saying, "I would like to give you money. Will you accept it?" Yep.
Is there a way to create an invoice not for a specific other participant, but for an invoice that, say, anyone can pay to for a certain amount of time?
So all invoices specifies the receiver, but they don't specify who pays it. So they all kind of work in that way, where I could post an invoice online and say, "Hey, anyone can pay it," but only one person can pay each invoice. One invoice means one payment. So is that what you meant, or?
Yeah.
Okay, yeah, all invoices are that way by default. I think you would have to break protocol to specify that only a certain node can send it. In fact, you don't even know who the sender is, so I don't think you even could. Yeah. Yeah, no, there wouldn't actually. That is a good point. Yeah, you don't know who sends to you, so there is no way to specify who sends to you. Yep.
So the invoice, like the customization, you said you could like customize the routes that you go through them?
You can suggest routes if they're able to, using their own graph, construct a route. You can't stop them from doing that. But for instance, those private channels I talked to are not announced to the network. So let's say you're a node, you only have private channels, but you do want to receive money. You have to include in the invoice some information that is not public to the graph, but that you are aware of. So you could say, "Hey, I'm like connected to my bank's node here. So if you want to route to me, you should route through my bank's node," something like that.
Is that just a field on the like invoice generation?
Yeah, usually it's usually not exposed to users. So it would be somewhere in the RPC API. I believe they're called route hints. Is what you'd be looking for, the route hints, not like, they don't prescribe the route. Cool. Oh, yeah.
Is there any way to just like say post address or QR and for, I don't know, donations or something?
Yeah. So that is a funny thing, right? Because it does sound like the obvious use case, just post your address, receive donations. It is not that easy because of the way invoices work, because you do need this thing to manually generate them. There are a few proposals on how to get around that. You touched on one with Sphinx. Yeah. Sphinx was supposed to, or is supposed to, alleviate that. Another way, so that was basically what I made with TipHub, was people were annoyed at that, and I was like, okay, I'll just run a server that talks to your node and generates a new invoice each time. And that's what it does. Yeah, it's a little tricky though, because even with Sphinx, your node has to be online to accept the payment, basically. So it will, the use case of receiving will never be as easy as it is on chain, unfortunately, because you're always going to have this always online node. You could imagine there being some form of escrow node though, that would be like a service that could take money for you, but it would be difficult to do that in a completely trustless way.
Neutrino help?
No, Neutrino is really only for syncing the node. I mean, it can make it easier to run a node on a mobile device or something like that, but even then, the phone's got to be connected to the network. Yeah, the case of receiving is definitely the most difficult to get to with a Lightning node. Cool. Any other? You want to talk about? All right, cool. Well, I will be around just if you want to talk about stuff, and definitely to help anybody who wants to get to the finish line with getting this thing set up. I will help anybody out who wants to do that. And if you want to host it online, happy to talk through what that looks like as well. Cool. Thanks, everybody.
All right. Say goodbye to YouTube.
Oh, yeah, bye, YouTube. I forgot you were there. Sorry. Should have repeated questions into the microphone. That would have been a good thing to do.